Every year, more than 125 million tons of bananas leave tropical plantations to feed billions of people. But few realize that this entire system relies on just a single banana variety on the planet. And the worrying part is, this variety has almost no natural defense against disease. In recent years, a soil-borne fungus called Panama TR4 has quietly spread across multiple continents, wiping out thousands of hectares of plantations in a short time. If it continues to spread, one of the most familiar fruits on supermarket shelves worldwide could disappear faster than we expect. But instead of accepting that risk, scientists, export plantations, and even the global cold chain logistics system have been forced to change the way bananas are grown, protected, and transported. So what is actually keeping this multi-billion-dollar banana industry from collapsing? Bananas first appeared in Southeast Asia around 7,000 years ago, before spreading along ancient migration routes to Africa, where they quickly became a staple food for tens of millions of people in East Africa, a role they still hold to this day. Today, bananas are grown in more than 130 countries worldwide. Among them, India is the largest producer, with over 37 million tons each year, mostly for domestic consumption. But when it comes to exports, the true center of the global banana industry is Ecuador, which supplies about 7 million tons annually, nearly 30% of the world's total banana exports. Thanks to their low cost, high energy content, and ability to be transported over long distances, bananas have become the most consumed fruit in the global supermarket system, while also providing a direct livelihood for more than 400 million people across tropical regions. However, the global banana industry nearly collapsed in the 1950s when a fungal outbreak known as Panama disease almost wiped out the dominant export variety at the time, Gros Michel, across Central America. Within just a few decades, hundreds of thousands of hectares of plantations were abandoned, forcing the entire global production system to switch to a single replacement variety, Cavendish. And now, as a new strain of the fungus, Panama TR4 has reached Latin America, the world's main banana export hub. More than 80% of the global export banana supply is under threat. Because of that threat, Ecuador has been forced to control banana cultivation from the moment young plants have not yet left the nursery. Today, bananas are almost never grown from seeds. Instead, plantlets are produced through tissue culture in laboratories, then planted in rows with a standard spacing of about 2 to 3 meters between each plant, ensuring proper airflow and slowing the spread of soil-borne diseases. From the earliest growth stages, soil moisture is carefully managed using drip irrigation or low-pressure spraying systems, typically supplying around 25 to 40 millimeters of water per week per hectare. This helps maintain a stable environment for root development without creating favorable conditions for fungal outbreaks. At the same time, a strict crop protection schedule is maintained. On large-scale plantations, fungicides and insecticides are applied regularly, often between 20 and 40 times per year. In many cases, agricultural aircraft fly directly above the banana canopy, creating an almost continuous protective layer across the entire field. Because Panama TR4 can survive in soil for decades, many plantations have also introduced strict biosecurity measures. These include disinfecting vehicle tires at entry points, limiting worker movement between planting zones, and monitoring each plantation area using digital disease mapping systems. Around the 7th month after planting, a large purple flower begins to emerge from the top of the banana plant, a clear sign that a bunch of fruit is starting to form. At this stage, farmers cover the entire flower bunch with specialized bags to protect the young bananas from insects, harsh sunlight, and strong winds, while also helping the fruit grow evenly and maintain the skin quality required for export. However, the protection process does not stop there. To prevent the plant from wasting nutrients on unnecessary parts, farmers remove the small flower tips at the end of each banana, then cut off the purple tail at the bottom of the bunch. A small step that helps concentrate all the plant's energy on the fastest growing fruit. After that, the banana bunch is sealed once again with protective covering to maintain a stable layer of protection throughout the entire development stage. Over time, banana bunches that have been protected and managed through multiple layers of control begin to grow rapidly beneath the dense canopy of the plantation. Once each fruit reaches the export standard size, the entire growing area immediately moves into the harvesting stage, a process that requires near-perfect precision to preserve the quality of every single bunch. This process is typically carried out by two workers working in close coordination. One holds the plant to control the direction it falls, while the other uses a sharp knife to cut the bunch stem at a point about 20 to 25 centimeters above the last hand, the necessary length to attach it to the plantation's internal transport system. Almost immediately, the heavy bunch, which can weigh up to 50 kilograms, is carefully supported on a padded shoulder to prevent scratches or bruising. Even a small mistake within those few seconds can cause the entire bunch to lose its export value. For this reason, in the global banana production chain, harvesting is not a simple final step, but a critical stage that determines the quality of everything that follows. Once cut from the plant, the journey of the banana bunch is far from over. Immediately after being lowered from the worker's shoulder, it is hooked onto overhead cable lines positioned about 1.5 to 2 meters above the ground, connecting the harvesting area directly to the processing facility. With pulleys and directional switches placed along the route, these banana trains can quietly travel several kilometers beneath the tropical canopy with almost no damage or scratches to the fruit surface. This system has almost completely replaced traditional manual transport methods, such as using horses or carrying loads by hand, significantly reducing labor effort while maintaining fruit quality throughout the journey. While a conventional truck can carry only about 35 to 40 banana bunches per trip and depends heavily on flat terrain, an internal plantation cable system can transport up to around 90 bunches at the same time, operating efficiently even across steep slopes, muddy ground, or plantations that remain wet year-round. When the last banana bunches are taken away, the mother plant has fulfilled its only purpose, because bananas are plants that flower just once, to prevent pests and diseases, and to make room for the next generation growing from the base. The trunk is shredded on site by chopper machines, returning nutrients to the soil in a quiet but complete cycle. However, not everywhere does the banana plant end its life this way. In countries such as India, the Philippines, and Vietnam, the remaining pseudo-stem after harvest is often kept to extract fiber, a natural biomaterial with a commercial value of about $300 to $600 per ton of raw material. After the mother plant is cut down, the thick, cellulose-rich outer layers of the pseudostem are separated from the soft inner core to retain the strongest fibrous structure. This material is then processed through mechanical extraction systems that pull it into long, continuous fiber strands, while still maintaining the plant's natural moisture. These raw fiber strips are then washed to remove plant sap and surface impurities. As excess moisture is reduced through natural sun drying, the fiber structure stabilizes and its tensile strength increases significantly. In the final stage, the dried fibers are twisted into light but durable threads, strong enough to withstand weaving and further processing. From there, they become raw material for products such as mats, handicraft bags, and various high-value bio-based materials for export. Time is a critical factor for bananas. Within about 4 hours after leaving the plant, the banana bunches must arrive at the packing facility to preserve maximum freshness and prevent early ripening from starting. At this stage, the protective bags used in the field are removed, revealing fresh green banana bunches still covered with dirt and plant sap after their journey through the plantation. Their first stop is a preliminary washing system, often described as an artificial rain, where continuous cold water sprays remove mud and impurities while also lowering the fruit's surface temperature to slow down its natural respiration process. After this initial cleaning, the banana bunches move to the central processing area. Here, workers quickly separate the large bunch into smaller hands using precise and decisive movements, preparing them for the next sorting stage. The banana hands are then placed into specialized cleaning tanks, where they are soaked for a controlled period to remove remaining sap and reduce the risk of fungal growth during long-distance transport. In the following stage, the banana hands are divided into smaller uniform clusters, typically weighing around 700 to 900 grams, matching export packaging standards. These clusters are immediately transferred onto conveyor belts for traceability labeling and final inspection before entering the boxing line. Throughout this entire process, low-pressure spray systems continuously wash away any remaining solution on the fruit surface while maintaining a stable temperature after treatment. This step is essential to preserve the banana's uniform green color before they enter the packaging stage and begin their cold chain journey across the ocean. Not all bananas continue their journey as fresh fruit. A portion of them becomes raw material for the food processing industry, especially for the production of export banana chips. After cleaning, the bananas are transferred to the peeling area, where skilled workers can handle between 400 and 600 fruits per hour with fast but highly precise movements. This step is critical because even a small scratch can cause the slices to curl or burn during the frying process later. From there, the bananas are fed into high-speed industrial slicing machines, where the blades are pre-adjusted to produce uniform slices of about 3 millimeters thick. This thickness is optimized so the outer layer becomes ideally crispy when fried, while the inner core still retains a firm texture and the natural sweetness of green bananas. Immediately after slicing, the banana pieces pass through a light washing conveyor to remove excess starch from the surface. They are then pre-dried at around 60 to 65 degrees Celsius to dry the outer layer and stabilize the structure of each slice. This step helps preserve the natural flavor before the slices are placed into the frying oil. The slices are then fried in oil at a temperature of about 160 to 180 degrees Celsius for 2 to 4 minutes to create an even crispy layer without losing their natural flavor. The temperature is tightly controlled to avoid burning the outside or causing excessive oil absorption. This step directly determines the crispness, color, and aroma of the final product. After that, they are coated with flavorful seasoning and immediately transferred to an automated packaging line, which can process around 8,000 to 10,000 packs per hour depending on package size. Each pack is precisely portioned, air-sealed to preserve crispness, and tightly sealed to maintain quality during long-distance transport. Finally, the packaged products are labeled with traceability codes and arranged onto export pallets, ready to leave the factory for supermarket shelves or to travel across oceans to markets around the world. Traceability allows full control over the product's journey from raw material to the end consumer. The pallets are then wrapped and loaded into refrigerated containers to maintain quality throughout transportation. If green bananas are used to make crispy snacks like chips or fried products, ripe bananas serve a completely different role. When the peel turns a bright yellow color, the starch inside has been converted into natural sugars, while the levels of vitamin B6, vitamin C, potassium, and fiber also reach an ideal level for the human body. Thanks to their easily digestible energy and mild sweetness, ripe bananas have become one of the most commonly consumed fruits on the tables of billions of people every day. Not only humans, but many wild animals also depend on bananas as an important food source. Monkeys, elephants, forest birds, and fruit bats are strongly attracted to the distinctive aroma of ripe bananas. As they eat, they unintentionally carry seeds and spread them across different areas of the forest, helping maintain the natural ecological cycle of tropical ecosystems. For this reason, ripe bananas not only feed humans, but also quietly connect and sustain the lives of many species. But the most important thing about bananas is not their taste or convenience. It lies in the silent role of the entire system behind them. Every year, the world consumes more than 400 billion bananas, and for hundreds of millions of people in Africa, South Asia, and Latin America, bananas are not a snack. They are a daily staple food. If bananas were to disappear within just a few years, the impact would not stop at supermarket fruit shelves. Millions of hectares of plantations would be abandoned. Millions of agricultural workers would lose their livelihoods, and the supply chain of affordable food for many developing countries would be immediately disrupted. Tropical ecosystems that depend on bananas as an intermediate food source for many animal species would also be affected. That is why today's precision farming techniques, strict disease control systems, and strategies to protect banana varieties are not just about increasing production. They are about safeguarding one of the most critical food links on the planet. Few people realize that behind a familiar banana lies a massive system quietly operating across tropical forests, seaports, and transoceanic shipping routes. It is not just a fruit, it is the result of precision, coordination, and scale that are sometimes only seen in mega-industrial projects. Each banana bunch leaving the plant marks the beginning of a global journey, connecting people to regions located half a world away. And perhaps the next time you hold a banana in your hand, you will see it in a completely different way. If you want to explore more stories behind massive systems like this, don't forget to like and follow Mandarin Tech.